Deep within the 6 million-ton limestone core of the Great Pyramid of Giza, sitting directly above the soaring corbelled ceiling of the Grand Gallery, lies a massive, untouched void that remained entirely invisible to human history for 4,500 years. It is a space nearly 100 feet long, constructed with massive stone engineering, sealed off from all known passageways, and buried so far beneath solid rock that no drill, flashlight, or optical camera had ever breached its perimeter. For centuries, Egyptologists believed every chamber within Khufu's monument had been mapped, catalogued, and debated. Yet, in late 2017, an international team of particle physicists proved that the greatest stone monument on Earth was still keeping secrets not by breaking through its ancient masonry with hammers or explosives, but by reading the invisible cosmic radiation raining down from deep space. To look through dozens of meters of solid, high-density limestone without drilling a single hole. The ScanPyramids International mission turned to a technology borrowed from nuclear particle physics, muon radiography. Muons are high-energy elemental particles created when cosmic rays from deep space collide with the upper atmosphere of Earth. Traveling at near the speed of light, billions of these invisible subatomic particles continuously bombard every square foot of the planet's surface. They can pass through solid rock, but as they traverse thick material like stone, they lose energy and are gradually absorbed. By placing specialized particle detectors deep inside the known lower chambers of the Great Pyramid, scientists could measure the precise trajectory and angle of every passing muon. Where the stone was solid and dense, fewer muons passed through. But where an empty room, cavern, or hidden vault existed overhead, a higher concentration of particles surged through unobstructed, creating a distinct, high-density shadow image on the detectors. The initial breakthrough was spearheaded by Nagoya University in Japan using delicate chemical nuclear emulsion plates placed inside the Queen's chamber. When these plates were retrieved, developed in specialized chemical labs, and analyzed under automated optical microscopes, the particle tracks revealed something that defied traditional architectural models. The data showed a massive, highly localized over-intensity of muon flux directly above the Grand Gallery. To ensure this was not a digital artifact or an anomaly caused by density variations in the limestone blocks, a second independent scientific team from the High Energy Accelerator Research Organization installed electronic scintillator detectors inside the pyramid. Simultaneously, French physicists from the CIA utilized gas-based micromegas detectors placed outside the monument. 3 entirely different particle detection technologies, operated by 3 separate teams of physicists, all converged on the exact same coordinate. A massive, horizontal or inclined void at least 30 meters long, with a cross-section nearly identical to that of the Grand Gallery. The announcement sent shockwaves through both civil engineering and Egyptology. The discovery of the ScanPyramids Big Void marked the first major internal structural discovery inside the Great Pyramid since the 9th century. Yet the moment the data was published, a fierce debate erupted regarding the function and structural necessity of this massive void. Skeptics argued that the anomaly might simply represent a series of construction gaps, unfilled spaces left behind by ancient workers to reduce the weight pressing down on the Grand Gallery below. Others suggested it could be a massive internal relieving chamber, similar to the 5 granite compartments stacked directly above the king's chamber. However, structural engineers pointed out a crucial difference. The Grand Gallery already utilizes a brilliant corbelled arch design, where each layer of limestone steps inward to channel overhead weight outward into the surrounding core stone. Adding a massive 30-meter empty space directly above a corbelled vault without structural support would present immense civil engineering challenges unless the void itself was designed with a specific, highly deliberate mechanical purpose. As particle physicists refined their 3D muon density models between 2018 and 2023, the resolution of the particle scans improved dramatically. By combining multi-angle detector arrays placed both inside the Queen's chamber and along the outer base of the monument, researchers were able to narrow down the precise spatial orientation of the space. The data confirmed that the Big Void is not a random cluster of small pockets or loose rubble filling. It is a continuous, structurally coherent void running parallel to or sitting directly above the Grand Gallery. The spatial volume is estimated to be over 200 cubic meters, a space large enough to hold a commercial passenger aircraft fuselage. Yet despite its enormous size, there are no visible doorways, no connecting shafts, and no physical corridors linking it to the known internal transit systems of the monument. While the world's focus remained locked on the mystery of the Big Void, the ScanPyramids team leveraged the same cosmic ray technology to investigate a second anomaly located on the north face of the monument. For decades, archaeologists had wondered about the purpose of four massive, chevrons-shaped limestone blocks visible on the exterior north wall, sitting directly above the ancient forced entry forced open by Caliph al-Ma'mun in 820 AD. In 2023, high-precision cosmic ray muon detectors combined with endoscopic testing delivered an extraordinary physical validation. The particle scans confirmed a smaller, distinct corridor located directly behind those chevrons. Using a microscopic 6mm optical endoscope inserted through a tiny pre-existing gap between the exterior stones, scientists captured the first live images of an unopened chamber, a pristine, 5-meter-long corbelled vault with sharp, untouched limestone walls that had remained untouched by human hands since the reign of Khufu. The successful physical confirmation of the north face corridor provided absolute empirical proof that the muon radiography models were exceptionally accurate. If particle physics could precisely locate and map a 5-meter corridor behind solid stone chevrons, the 30-meter Big Void sitting deeper in the pyramid's core is unequivocally a real physical structure. The discovery of the north face corridor also provided a crucial clue regarding internal pyramid design. The corbelled chevrons above that corridor were designed specifically to distribute massive vertical weight away from a hidden passage. Because similar gabled chevron blocks sit directly above the king's chamber and the main entrance, engineers now speculate that the Big Void may also be protected by massive stone chevrons, preserving its structural integrity beneath millions of tons of overhead weight. This raises the ultimate question that modern non-invasive archaeology is racing to answer. What sits inside the Big Void? Is it an ascending construction ramp used by the builders to haul multi-ton granite blocks into the upper chambers before being sealed into the core? Is it a second, hidden Grand Gallery leading to an unlooted royal burial room that early tomb robbers completely missed? Or is it a master structural relief feature designed to allow the Great Pyramid to withstand major seismic events without collapsing? Because Egyptian heritage authorities strictly prohibit any destructive drilling or invasive excavation into the primary core of the monument, answers can only come through next-generation, non-invasive technologies. Currently, advanced international research consortia are preparing hyper-resolution muon telescopes capable of mounting long-term observations around the base of Giza. These next-generation detectors utilize artificial intelligence neural networks to filter out background cosmic noise, producing 3D tomographic models of the internal stone core with centimeter-level precision. At the same time, robotics engineers are developing miniature, snake-like robotic probes designed to navigate through tiny interstitial gaps between blocks to reach the perimeter of the void without displacing a single stone. Today, the Big Void remains sealed in absolute darkness and absolute silence, suspended in stone high above the millions of tourists who walk through the Grand Gallery every year. The physical reality of its existence is no longer a matter of historical speculation. It is an established scientific fact, mapped by subatomic particles born in distant deep space supernova explosions. Through the lens of cosmic ray physics and 3D density modeling, modern science has peeled back the heavy stone walls of Giza to reveal a vast, pristine frontier buried within the ancient world's most iconic masterpiece.